Scientists got a surprise when NASA's Perseverance Mars rover began examining rocks on the floor of Jezero Crater in spring of 2021. Because the crater held a lake billions of years ago, they had expected to find sedimentary rock, which have formed when sand and mud settled in a once watery environment. Instead, they discovered the floor was made of two types of igneous rock, one that formed deep underground from magma, the other from volcanic activity at the surface. The findings are described in 4 new papers published Thursday, August 25. In Science, one offers an overview of Perseverance's exploration of the crater floor before it arrived at Jezero's ancient river delta in April 2022. A second study in the same journal details distinctive rocks that appear to have formed from a thick body of magma. The other 2 papers published in Science Advances detail the unique ways that Perseverance's rock vaporizing laser and ground-penetrating radar established that ingenious rocks covered the crater floor. Rock of Ages. Close-up image of a rock target nicknamed Folks. Watson views a rock target named Folks. Perseverance took this close-up of a rock target nicknamed Folks using its Watson wide-angle topographic sensor for operations in engineering camera, part of the Sherlock instrument on the end of the rover's robotic arms. The image was taken July 11, 2021, the 139th Martian day or Sol of the mission. Ingenious rocks are excellent timekeepers. Crystals within them record details about the precise moment they formed. One great value of the ingenious rocks we collected is that they will tell us about when the lake was present in Jezero. We know it was there more recently than the ingenious crater floor rocks formed, said Ken Farley of Caltech, Perseverance's project scientist and the lead author of the first of the new science papers. This will address some major questions. When was Mars's climate conducive to lakes and rivers on the planet's surface? And when did it change to the very cold and dry conditions we see today? However, because of how it forms, igneous rocks isn't ideal for preserving the potential signs of ancient microscopic life Perseverance is searching for. In contrast, determining the age of sedimentary rock can be challenging, particularly when it contains rock fragments that formed at different times before the rock sediment was deposited. But sedimentary rock often forms in watery environments suitable for life and is better at preserving ancient signs of life. That's why the sediment-rich river delta Perseverance has been exploring since April 2022 has been so tantalizing to scientists. The rover has begun drilling and collecting core samples of sedimentary rocks there so that the Mars sample return campaign could potentially return them to Earth to be studied by powerful lab equipment too large to bring to Mars. Mysterious magma-formed rocks. A second paper published in Science solves a long-standing mystery on Mars. Years ago, Mars orbiters spotted a rock formation filled with the mineral olivine. Measuring roughly 27,000 square miles, 70,000 square kilometers, nearly the size of South Carolina, this formation extends from the inside edge of Jezero Crater into the surrounding region. The agency's lander felt the ground shake during the impact while cameras aboard the Mars Reconnaissance Orbiter spotted the yawning new crater from space. NASA's InSight lander recorded a magnitude 4 Mars quake last December 24, but scientists learned only later the cause of that quake, a meteoroid strike estimated to be one of the biggest seen on Mars since NASA began exploring the cosmos. What's more, the meteoroid excavated boulder-sized chunks of ice buried closer to the Martian equator than ever found before, a discovery with implications for NASA's future plans to send astronauts to the Red Planet. Scientists determined the quake resulted from a meteoroid impact when they looked at before and after images from NASA's Mars Reconnaissance Orbiter, MRO, and spotted a new yawning crater, offering a rare opportunity to see how large an impact shook the ground on Mars. The events and its effects are detailed in 2 papers published Thursday, October 27, in the journal Science. The meteoroid is estimated to have spanned 16 to 39 feet, 5 to 12 meters, small enough that it would have burned up in Earth's atmosphere, but not in Mars's thin atmosphere, which is just 1% as dense as our planet's. The impact in a region called Amazonis Planitia blasted a crater roughly 492 feet, 150 meters across, and 70 feet, 21 meters deep. Some of the ejecta thrown by the impact flew as far as 28 miles, 37 kilometers away. With images and seismic data documenting the event, this is believed to be one of the largest craters ever witnessed forming any place in the solar system. Many larger craters exist on the Red Planet, but they are significantly older and predate any Mars mission. Scientists have offered various theories why olivine is so plentiful over such a large area of the surface, including meteorite impacts, volcanic eruptions, and sedimentary processes. Another theory is that the olivine formed deep underground from slowly cooling magma, molten rock before being exposed over time by erosion. Yang Liu of NASA's Jet Propulsion Laboratory in Southern California and her co-authors have determined that last explanation is the most likely. Perseverance abraded a rock to reveal its composition. Studying the exposed patch, the scientists home in on the olevine's large grain size along with the rock's chemistry and texture. Using Perseverance's planetary instrument for X-ray lithochemistry, or PIXL, they determined the olivine grains in the area measure 1 to 3 millimeters, much larger than would be expected for olivine that formed in rapidly cooling lava at the planet's surface. This large crystal size and its uniform composition in a specific rock texture require a very slow cooling environment, Liu said. So most likely this magma in Jezero wasn't erupting on the surface. Unique science tools. The two Science Advances paper details the findings of science instruments that helped establish that igneous rocks cover the crater floor. The instruments include Perseverance's SuperCam laser and a ground-penetrating radar called RIMFAX, radar imager for Mars's subsurface experiment. SuperCam is equipped with rock vaporizing laser that can zap a target as small as a pencil tip from up to 20 feet, 7 meters away. It studies the resulting vapor using a visible light spectrometer to determine a rock's chemical composition. SuperCam zapped 1,450 points during Perseverance's first 10 months on Mars, helping scientists arrive at their conclusion about igneous rocks on the crater floor. In addition, SuperCam used near-infrared light. It's the first instrument on Mars with that capability to find that water-altered minerals in the crater floor rocks. However, the alterations weren't pervasive throughout the crater floor, according to the combination of laser and infrared observations. SuperCam's data suggests that either these rock layers were isolated from Jezero's lake water or that the lake existed for a limited duration, said Roger Wyans, SuperCam's principal investigator at Purdue University and Los Alamos National Laboratory. RIMFAX marks another first. Mars orbiters carry ground-penetrating radars, but no spacecraft on the surface of Mars have before Perseverance. Being on the surface, RIMFAX can provide unparalleled detail and survey the crater floor as deep as 50 feet or 15 meters. Its high-resolution radargrams show rock layers unexpectedly inclined up to 15 degrees underground. Understanding how these rock layers are ordered can help scientists build a timeline of Jezero Crater's formation. As the first such instrument to operate on the surface of Mars, RIMFAX has demonstrated the potential value of a ground-penetrating radar as a tool for subsurface exploration, and Svein Erik Hamren, RIMFAX's principal investigator at the University of Oslo in Norway. The science team is excited by what we've found so far, but they're even more excited about the science that lies ahead. Crater hunters. In late 2021, InSight scientists reported to the rest of the team they had detected a major Marsquake on December 24th. The crater was first spotted on February 11, 2022 by scientists working at Malin Space Science Systems MSSS, which built and operates two cameras aboard MRO. The Context camera, CTX, provides black and white medium-resolution images, while the Mars Color Imager, MARSI, produces daily maps of the entire planet, allowing scientists to track large-scale weather changes, like the recent region dust form that further diminished inside solar. The impact's blast zone was visible in MARSI data that allowed the team to pin down a 24-hour period within which the impact occurred. These observations correlated with a seismic epicenter, conclusively demonstrating that a meteoroid impact caused a large December 24 Marsquake. The image of the impact was unlike any I have seen before, with a massive crater, the exposed ice, and the dramatic blast zone preserved in the Martian dust, said Lilia Poshilova, who leads the Orbital Science and Operation Group at MSSS. I couldn't help but imagine what it must have been like to witness the impact, the atmospheric blast, and debris ejected miles downrange. Establishing the range at which craters appear on Mars is critical for refining the planet's geologic timeline. On older surfaces, such as those of Mars and our moon, there are more craters than on Earth. On our planet, the processes of erosion and plate tectonics erase older features from the surface. New craters also expose materials below the surface. In this case, large chunks of ice scattered by new impact were viewed by MRO's high-resolution imaging science experiment, HiRISE Color Camera. Subsurface of ice will be a vital resource for astronauts who could use it for a variety of needs, including drinking water, agriculture, and rocket propellant. Buried ice has never been spotted this close to the Martian equator, which, as the warmest parts of Mars, is an appealing location for astronauts. More about the missions. JPL manages InSight and the Mars Reconnaissance Orbiter for NASA's Science Mission Directorate. InSight is part of NASA's Discovery program managed by the agency's Marshall Space Flight Center in Huntsville, Alabama. Lockheed Martin Space in Denver built the Mars Reconnaissance Orbiter, InSight spacecraft including its cruise stage and lander, and supports spacecraft operations for both missions.